In this video, what I'm going to do is I'm going to talk about voltage drop. It's an extremely important concept when it comes to diagnosing electrical circuits, especially in vehicles. It's actually a concept, the voltage drop concept, and how to test for voltage drop. It's something that even you go to a lot of dealerships or independent shops, and the technicians don't really understand it so much as well. Okay, so I guess consider yourselves a little bit privileged that you guys get to really understand what voltage drop is, what it means. Okay, so voltage drop is uh, is a way to identify the health of a circuit. Okay, so remember, voltage is the amount of pressure that's available at as stored energy at any point in the circuit, or of power. Okay, but and then resistance is the amount of resistance to that pressure, and then you get, as an effect, amperage, which is the flow of electrons. So the higher the resistance, the lower the flow, based on your electrical pressure, your voltage. Okay, now when you diagnose a circuit, a lot of people, what they'll do is they say, oh, well, my bulb isn't working very well. So they'll say, oh, what I need to do is I need to figure out if there's resistance somewhere else in the wires. Well, if I check resistance real quick, this doesn't tell me a lot. I could come over here to again, when you check for resistance, when that is necessary, you'd check across, you'd isolate the component, and then you'd check across that. So this bulb has 2.7 ohms of resistance. Okay. If I come to this wire over here and I isolate that wire, the amount of resistance that I get is about half an ohm. Or no, sorry, zero point 0.2 ohms. Okay. Um, that's within reason, within acceptable, within tolerance. If I check this power wire on either side, zero point 0.2, zero point 0.3 ohms. Okay. You will always have a little bit of resistance in these wires. Now, one of the reasons why just checking for resistance is not a good test when you're experiencing issues with the circuit is because a mouse, which they often do, mice, rodents, rabbits, birds, I've seen birds get into places where they start chewing into wires, and in this stranded wire, they might get it to the point where there is only one strand of wire left. Now, if I check resistance on that wire and there was only one strand left, I would still get zero point 0.2, zero point 0.3 ohms. That's not going to change, okay? Because this multimeter is putting out just a trickle of voltage. All that ohms really checks is, for the most part, is going to be continuity. In other words, is it continuous? Well, if you have one strand of wire, yeah, it's continuous. Okay. But does that mean that this wire can handle the load of a bulb or a motor or something like that if it's only got one strand left? And that answer is no. Okay. Or it might for a time, but then it's going to burn up. So the best way to check the health of your circuit is to check it live. And that is by using voltage drop. It's a different test. Okay. So I'm going to hook this all up. Now I've got my bulb here, and when we think about the amount of voltage that should be consumed anywhere in the circuit, the majority of the voltage should be consumed at the load itself, whether it's a bulb or a motor or some other kind of resistor. Basically, the thing that you want to do work needs to be consuming the majority of this voltage rather than the wires. Again, there will always be a little bit of resistance in the wires, so they will always consume a little bit of the voltage, but the majority, again, needs to come through that thing you want doing the work. All right. So what I'm going to do is I'm going to change this now to volts DC, and I'm going to turn on my battery, and you can see that this bulb is lighting well enough. All right. Now I'm going to check to see what the voltage drop is across this bulb. how much of that power of the source voltage, which if I come over here, 12.51 volts, is being consumed by this bulb. So I come over here and I see 12.44 volts, 12.44, 12.45 volts. That means that's good, okay? The majority of my voltage from my source is being consumed at my bulb. This is a healthy circuit. Now what if I was only seeing zero point 0.1 volts being dropped across there, across this bulb? That would mean that there is something going on somewhere else in the circuit that is consuming the voltage that should have been consumed by this bulb, all right? In that case, what you would do is, again, you'd check for volts. Now, we're not going to see that in this case because this is a healthy circuit, but same thing. I could come to one side of the circuit to my power wire, and I could check just that power wire, and I could see, and I could identify how much voltage is being consumed along that wire. In this case, about 2/100ths of a volt, okay, is being consumed there. But say that was the problem. If this was only consuming 0.1 volts and you were dropping 12 volts along this wire where no work should be taking place, really, um, that wire would be the issue. What about this? What if I pretend that I have a fuse that is blown? Okay, so I'm just going to take it out of the circuit. I turn this on. Oh no, my bulb isn't lighting. Okay, so I come over here and I'm checking voltage and I'm seeing 0 volts. There is nothing being dropped across that. So I come over to my power wire and I try to figure out what's being dropped across that. Hey, look at that, 12.5 volts. So there's a problem in this circuit, and I could then narrow it down to this fuse if it was blown, right? Put that back in, it works again. And then the same thing for the ground side. I would go from one point to the other. I'd expect to see closer to 0 volts being dropped across this side. If there's too much more than that, if this bulb was dropping only 6 volts, and I determined that the power side of this wire was fine, or the power side of the circuit was fine, I could just go straight to the ground side of the circuit, and I could measure that. And in this case, of course, it's healthy. We're only dropping about 0.03 of a volt. But maybe there was 6 volts being consumed across there. Well, now I know that there's probably uh, extra corrosion in the wire or something like that, and that would condemn this side of the circuit, and I'd either have to do a good repair or replace the harness. In some cases, it just depends on the extent of the damage. So that is voltage drop. Again, voltage drop is to measure the health of a circuit when it is live, based on 2 points within the circuit. And again, what you'd like to see is that the majority of your source voltage is being consumed by the component that should be doing work. In this case, a bulb, but again, there's a lot of other components that we have in automotive that do work. If you have any questions about voltage drop, please reach out and let me know.